Hello everybody, today's video focuses on the type of questions that could crop up on paper 2 concerning the required practicals. The first required practical that we did in year 11 was rates of reaction, and we investigated the various factors that affect the rate of the reaction between sodium thiosulfate and hydrochloric acid. So initially I wanted to just remind you of the method. In the exam, they could give you the method like they have done in this question, or alternatively, they could ask you to write the method. If you are asked to write the method, then make sure you are getting to the point, you do it in bullet points, and you don't describe parts of the method that are unnecessary. For example, I measured the hydrochloric acid whilst my partner measured the sodium thiosulfate. You don't need to include that, you just need to be quite basic and get to the point. The other thing concerning this method is that this one describes the method where temperature was the variable that affected the rate of the reaction. You could also be asked to write a method whereby concentration was the variable that affected the rate of the reaction. And in that case, it would just be this second point here in your method that you would have to change. And therefore you would just put select the correct concentration of sodium thiosulfate. Equally, they generally include the word equation for the reaction that's being carried out. Again, this can give you really good vital information for future questions. And if you have a look at this, not only does it give you the formulas, but it also gives you the state symbols, because quite often they will ask you, why did the reaction mixture go cloudy? And it goes cloudy because a precipitate was made, which is where you have a solid that floats in a solution. And the state symbols will lead you to that point. This type of question also always crops up on paper 2. It will ask you to explain the effects of increasing temperature or the effects of concentration. In this question, it specifically asks you to explain in terms of particles and collisions, so you must include those words in your answer and refer to them. So for this question, first of all, you need to start off by mentioning that when the particles are heated, they gain kinetic energy. And that will be your first 2 marks. Secondly, if they've got more kinetic energy, the particles will be moving around more, and therefore there's more likelihood of a collision. And it does ask you in the question to refer to particles and collisions. If you've got more collisions, then of course the rate of reaction will increase. If the subject of the question is concentration, your explanation is a slight bit different, but not much. It just centres around the fact that if you increase the concentration, there will be more active particles. Again, you're referring to the particles. And if there are more active particles, again, there is more likelihood of a collision. And therefore the rate of reaction increases. Obviously, you could talk about the concentration decreasing and how that would have an effect on the rate of reaction as well. This question focuses on the effect of metal carbonates and acids to measure the rate of the reaction, and uses the method of measuring the volume of gas produced using an upside down measuring cylinder. And then the questions go on to ask you to interpret the resolution of the scale on the measuring cylinder. So make sure in the first instance that you've looked carefully at all the information given in the question. And you can see here that in the original diagram, the measuring cylinder is upside down. So first of all, when you're looking at the resolution, check which way your scale is going. And we can see here that the smaller numbers are at the top, going down to the bigger numbers further down. So we've got 140, 150, 160. Secondly, to work out the resolution, firstly, check out the size of the difference between the two major numbers. So between 150 and 160, there's a difference of 10. We look at the number of increments between that, and we've got 1, 2, 3, 4, 5. 10 divided by 5 equals 2. So therefore, each little line represents 2. Don't count backwards from 160. Always go in the way which the numbers would go logically. And so when we look here, we can see that we've got 100, 152, 154, 156, and here between the two lines is 157. And if it's in a measuring cylinder, then it's got to be centimetres cubed. Unfortunately, moles, mass and MR crops up on both papers, so I'm sorry if you thought it was only going to crop up on paper 1, but you still need to make sure you can recall and use the equation for calculating either moles, mass or MR. And don't forget, MR stands for the molar mass of either the element or the compound. In this case, it's just like the ones that you've done on paper 1. And so use the every method and also bug the question when you get started. So when we look at this one, the question asks us to calculate the amount in moles of carbon dioxide in 0.32 grams of carbon dioxide. It's asking us to calculate the amount of moles, so that's what I'm going to box off. And then it also gives us the mass of the carbon and oxygen in carbon dioxide. Now again, this regularly happens in these questions. It looks like they're giving you the overall mass, so don't get mixed up. Carbon dioxide has 2 atoms of oxygen in it. So when you're calculating the MR in the first instance, don't forget that it's going to be 2 times oxygen. So therefore, the MR of carbon dioxide is 12 plus 16 plus 16, which equals 44. So don't forget, carbon dioxide is always 2 atoms of oxygen. As you've always done, use the every method to resolve any of these questions. And I would always encourage students to remember the equation for calculating moles, mass or MR in the format of moles equals mass divided by MR. So the V stands for the values of the variables. Now we're calculating the amount of moles, and the value of our mass from the question is 0.32 grams, and our MR that we've worked out up here of carbon dioxide is 44. The second E stands for the equation with substitution. So this time we write in moles equals, we put in our numbers or our values, 0.32 divided by 44, and then it gives you here a line for your answer. If you put that into your calculator, it comes to 0.007 moles. Chromatography crops up in the second topic that we did in Year 11, chemical analysis. And because you can't physically make a chromatogram, they will generally include a question like this one that asks you to identify errors in setting up the apparatus, and it will give you a diagram, as it has, of the setup. Generally, there are only 2 errors that crop up, and that is around the height of the solvent and the start line. And we can see from the labels on this diagram, the start line has been drawn in ink, and we can also see that the solvent line is above the start line. So like I always say, look carefully at any diagrams that you are given, especially when they're asking you to identify problems with it. So like I said, generally the two problems that are associated with it is that the start line is drawn in ink. If it's in ink, the ink will dissolve, and therefore it will dissolve and mix the spots. So that's your first mark. Secondly, if the solvent line is above the start line, the samples or your spots under the solvent line will wash off the paper or dissolve laterally. They will also generally ask you to explain how chromatography actually separates substances. The general misconception is where students refer to the size of the particles rather than the scientific explanation, which is the distance travelled depends on their electrostatic attraction to the paper. In the first instance of any explanation, you must mention the mobile phase, which is the solvent as it moves up the paper. And this allows the substances to dissolve. Secondly, you must mention that it is the solvent that carries the substances different distances. And then finally, your last bit, this is the actual explanation, and the distances that the spots travel depends on, like I said, the electrostatic forces of attraction between the spots and the paper. The final required practical in the chemistry curriculum was to calculate the mass of dissolved solids in 3 different samples of water. Sometimes it can feel a bit overwhelming when you're given a results table and it's not something that you've really looked at that regularly, and also when it's not regular calculations where we've perhaps used the every method. So when given a table, the first thing I always say is to check out the titles of the columns. And we can see here we've got 3 different types of water. The first column is the watch glass or the mass of the watch glass. The second column is the mass of the watch glass and the dissolved solids. And so we can see then in column 3 that if we subtract the watch glass from the watch glass and dissolved solids, then we end up with 0.14. And then our final column is actually the dissolved solids in 1,000 cubic centimetres of water. And so they've scaled up from 5 cubic centimetres up to 1,000. So in order to have calculated this figure here, they will have divided 1,000 by 5, which equals 200. And they have then done 200 times 0.14, which equals 28. So once you've worked out how they've done the first full line, you can then apply that to the missing value. So we know that there are 0.08 grams of dissolved solid in 5 cubic centimetres of water. We already know there are 200 fives in 1,000. So simply our little equation is 200 times 0.08, and therefore our answer comes to 16 grams. It's always important, whichever the question, always look at the titles of the columns, look at what you're dealing with in your first column, and that will always help to lead you to how to solve that question. This type of question generally tends to crop up associated with this required practical. I doubt they will ask you to calculate a straightforward percentage because that's too easy. This question, it gives you the percentage by mass of the dissolved solids in 650 grams of a sample, and it tells you that it's 2.2%. So it's a little bit more complex because you have to convert the percentage back to numbers and then work it out. So I would start off by doing 2.2 divided by 100, and then we multiply it by the value of the mass, which is 6.50, and we put that into our calculator and our answer is 0.143. Generally though, you would put your answer in the same format as the question. So don't leave it as 0.143. They've only used 2 decimal places in the question. So make sure you keep in that vein and do your answer then as 2 decimal places. So on the line that's provided, 0.14 grams. Finally, I just want to say good luck tomorrow. You've worked really hard all year. We've worked you hard, and people who work hard get good grades. So good luck tomorrow. You're going to smash it.